Hello, greetings everybody. Welcome to my video tutorial. In this video tutorial, I will explain the laws of indices or the rules of indices. If m and n are positive integers and a, b are members of real numbers, then we have the following rules. Rule number 1, we will consider the product rule. Now this rule states that a exponent m times a exponent n will give us a exponent m plus n. That is, for instance, if you have 3 exponent 2 times 3 exponent 4, if you are saying this will be the same as 3 exponent 2 plus 4, which gives us 3 exponent 6. Now logically, you see that this is true because 3 exponent 2 is the same as 3 times 3. Okay, and 3 exponent 4 is the same as 3 times 3 times 3 times 3. And we all agree that if you are to multiply this one, if you have 3 times 3 times 3 times 3 times 3 times 3, which gives us 3 exponent 6. Hence, we see that if you are multiplying two indices which have the same base, take note that the bases here are the same, that is base 3 and base 3. Then you can simply simplify by adding their exponents or their powers. That's 3 exponent 2 plus 4, which gives us 3 exponent 6. Hence, this rule is true. Now, rule number 2, or the second law, that you consider is the quotient. The quotient rule. Now, this rule also states that a exponent m over a exponent n will give us a exponent m minus n. That is, if you are dividing two indices which have the same basis, then we can simplify by subtracting the exponent as you have here. So, example. So, for instance, 3 exponent 4 over 3 exponent 2 will give us 3 exponent 4 minus 2. This gives us 3 exponent 2. And again, this is true because 3 exponent 4 is the same as 3 times 3 times 3 times 3 all over 3 exponent 2 is 3 times 3. And if you have to cancel, 3 cancel 3, 3 cancel 3, you have 3 times 3. And you all know that 3 times 3 is the same as 3 exponent 2, which gives us the same answer. Hence, if you have two indices that are dividing, you can simplify by writing the base exponent, the difference of the exponents here. Now, the next rule or the next law, 3, is the power rule and power of a product or quotient rules for exponents. And that is the first one that you consider states that a exponent m or exponent n is equal to a exponent mn. As the m multiplies the n. For instance, or example, 2 raised to power 3 or exponent 2 gives us 2 raised to power 3 times 2, which gives us 2 raised to power 6. And again, you see that this is true because if you have to expand this, 2 raised to power 3 or exponent 2 implies that 2 raised to power 3 times 2 raised to power 3, That's 2 raised to what term is multiplying itself 2 times. And if you are to expand this one, this will give us 2 times 2 times 2, all in brackets, times 2 times 2 times 2. And simplifying this gives us 2 times 2 times 2 times 2 times 2 times 2, which gives us 2 raised to what 6. Hence, we see that if you have 2 raised to what 3 or exponent 2, you can simplify by just multiplying their exponents. That is 3 times 2 to get 2 raised to what 6 without expanding as I have done below. Under this same rule, if you have a, b, or exponent m, they will say this is the same as a exponent m times b exponent m. That is a, b in bracket or exponent m means the m affects the a and also affects the b separately. So hence we have a raised to the power m times b raised to the power m. So for instance, or example, if you are given 2s or exponent 2, it will say this is the same as 2 raised to the power 2 times s raised to the power 2. Now you see that the exponent 2 here affects the 2 separately and also affects the s separately. So simplifying this one will give us 2 raised to the power 2, which is 4. So you have 4 times s raised to the power 2, that's s squared. Simplifying gives us 4s squared. Now again, you see that this rule is also true because 2s raised to the power 2 is same as 2s times 2s. And if you have to expand it, it is same as 2 times s. That's 2s is the same as 2 times s times 2s, that's 2 times s. Grouping this gives us 2 times 2 times s times s. And we all know that 2 times 2 is 4. And s times s is s squared. It is the same as the answer that we have above here. Now we have a final sub rule under this rule, which deals with the quotient. That's I. Now this rule states that a over b or exponent n is equal to a exponent n over b exponent n. So example, if we have 4s exponent 2 all squared, you will say this is the same as 4s all squared over 2 squared, or 4s exponent 2 over 2 exponent 2. Taking that the 2 here affects the 4s separately and also affects the 2 at the denominator separately. Simplifying this gives us 4 squared times s squared all over 2 squared. This gives us 4 squared is 16, that's 16 s squared over 4. Simplifying further, 4 will go into 16, 4. That gives us 4s squared. This states that a exponent 1 over n is equal to the nth root of a. For instance, if you have 4 exponent 1 over 2, then this is same as the square root of 4, which is same as 2. Normally, we don't write the 2 when we have exponent 1 over 2. Or if you have 8 exponent 1 over 3, then this implies that the cube root of 8, which also gives us 2. Also, if you have a exponent m over n, then this is same as the nth root of a or exponent m. And we know this is same as the nth root of a is a exponent 1 over n or exponent m. So simplifying this one gives us a exponent 1 over n times m, which gives us m over n. So for instance, if you are given 4 exponent 3 over 2, then you can simplify this by writing this as the square root of 4 all cube. You know, the square root of 4 is 2. So we have 2 exponent 3, which gives us 8. Now, I'll also explain the zero and the negative exponent properties of indices. And the first one, the zero exponent property, very simple. We say that if a is not equal to 0, then a exponent 0 is equal to 1. For example, 7 raised to power 0 will give us 1. The same way, minus 7 raised to power 0 will give us 1. If we have 2s plus 5 raised to power 0, it will still give us 1. So, for any expression raised to power 0 will give us 1. And the second one, that is the negative exponent property, states that a raised to power minus n will give us 1 over a raised to power n. For example, 2 raised to power minus 3 will give us 1 over 2 raised to power 3. Now, what if you have an exponent that is a negative fraction? Like, for example, 4 raised to power minus 3 squared. We can still simplify by writing this as the reciprocal of 4 as 1 over 4 or exponent 3 over 2. That is, you try to remove the minus exponent, the minus first. And simplifying this gives us 1 exponent 3 over 2 all over 4 exponent 3 over 2. You know, 1 exponent 3 over 2 is same as 1. 4 exponent 3 over 2 is same as the square root of 4 or cube. This gives us 1 over 2 cube. And finally, we have 1 over 8. Thank you for watching this video tutorial. In our next lesson, you'll solve some more examples using these rules and properties for a more better understanding. Thank you. Bye-bye.